Hello students, you have studied the different methods of solving simultaneous equation. Number one, that is equating coefficient method. Second one, by eliminating variables. Third one, that is graphical method. Then today we are going to study about the one more method of solving simultaneous equation, that is determinant method, or it is also known as Cramer's rule. We can solve simultaneous equations. Then first of all we have to discussing on what is determinant. What is determinant? Then see here, determinant is written like this. See here, A, B, C, D, R, these are indeterminate. That means it is a determinant. It is a determinant in which there are two columns are there. In one column A and C, two different elements are there, and in second column B and D, two different elements are there. Similarly, in column 1 and 2, two elements are there. Like that, in two rows, row 1 and row 2, in both rows two elements are there. Therefore the degree of this determinant, is 2. Determinant is 2. Then see here, we can find out the value of this determinant by using rules of determinant. See here, the cross arrow is drawn here which points A to D. Therefore, to find out the value of this determinant, we have to multiply first A into D. That means AD minus, then the remaining two elements, that B and C are there. Therefore, multiplying B and C, and here the value of this determinant can be calculated by AD minus BC. That is the value of given determinant. Then see here, any determinant can be written or it can be represented by capital letters like that. Suppose this determinant is represented like this, that is A is equals to determinant given here. Then we will solve few examples to find out the values of determinant. Then see here, practice set 1.3, in which there are examples are given of finding out the values of determinant. In question number 1, the activity is given here. You will solve it later. I am going to discussing with you the examples from question number 2. When we solve the examples from question number 2, then you can solve the activity which is given in the question number 1. Then first of all, see here, there are 3 examples are given. Then the first example, -1, 7 and 2, 4 are in determinant. Therefore, first of all, we have to represent that determinant, that is A is equals to the given determinant -1, 2, 7, 4. Then to find out the values of this determinant, then we can use the formula or rule of finding the value of determinant. Then only one arrow should be done here, that is pointing from this element to this element. Then that indicates that इथं फक्त एकच एरो दाखवायचा. पुस्तकात 2 एरो दिले पण जम्बलिंग होणार आपल्याला 2 एरोमुळे, त्यामुळे आपण एकच एरो दाखवायचा की ज्याच्यामुळे वी कॅन फाइंड आउट द व्हॅल्यू ऑफ गिवन डिटर्मिनंट. देन मल्टिप्लाय -1 by 4 minus, then the remaining 2 elements, that is 2 into 7. Therefore -1 into 4 -4, the sign minus, that is minus 2 into 7 14. Therefore we get the value of determinant -4 minus 14, that is -18. Therefore value of this determinant is -18. Then see here, one more example is there, that is third example, in which the elements in the determinant is given in the form of fractions, that is 7/3, 5/3 and 3/2 and 1/2 are in determinant. First of all, we have to represent that determinant by any capital letters, that is P. See here, P is the determinant in which elements are in fraction. Therefore, according to rule, we have to multiply by 7/3 by 1/2 minus 5/3 into 3/2. Bracket should be drawn here. इथं आपल्याला ब्रॅकेट घालावाच लागेल, otherwise we cannot find out the answer correctly. Then multiply 7/3 into 1/2, that is 7/3 into 2 6 minus 5 into 3 15/3 into 2 6. Then see here, 7/6 minus 15/6. Here denominator are same, isn't it? Therefore we can find out the value like this: 7 minus 15/6, isn't it? Therefore 7, the sign of 7 is plus and sign of 15 is minus. Therefore we have to write sign minus. 15 is greater than 7, therefore 15 minus 7, that is 8, minus 8/6. Then simplify that 8/6. 8 is divided by 2, divisible by 2, as well as 6 is divisible by 2. Therefore 2 4s are 8 and 2 3s are 6. Therefore the value of the given determinant is -4/3. That is about the examples to determine the values of determinant. Then you may do the practice of these type of examples. The same type of activity is given in the question number 1. You will solve it later. Then we will discussing on the determinant method to solve the simultaneous equations. And when we use the rule of determinant to solve the simultaneous equation, that is also known as Cramer's rule, then according to Cramer's rule, we can solve the simultaneous equation. Then first of all, we have to understand how to solve simultaneous equation by Cramer's method or Cramer's rule. Then see here, let us consider, suppose there are two different linear equation in two variables. Generally, a1x plus b1y is equals to c1. That is the one of the linear equation in two variable. Let this equation number 1. Then the second one linear equation in two variable in simultaneous equation is a2x plus b2y is equals to c2. Let this equation number 1. Then set of these two linear equation in two variable is a simultaneous equation. Then first of all, we have to write the determinants. Determinant. Three types of determinant we have to write for these equations to solve these equations. हे इक्वेशन सॉल्व करायला पहिल्यांदा आपल्याला तीन टाइपचे डिटर्मिनंट लिहावे लागतील. Then see here, first determinant which is denoted by D. Then see here, determinant D should be written like this: A1, B1, A2, B2. That means here the A1 values of A1, B1 and A2, B2 are considered to write the determinant D. Then the second determinant, that is dx, is equals to here C1, B1 and C2, B2 elements are used. That is C1, B1 and C2, B2 values are used to write the determinant for x, that is dx. Similarly, we can write the determinant dy, and here the A1, C1 and A2, C2 elements are used for this determinant dy. Then we can calculate the values of these all. That is D is equals to, then how to calculate the value of this determinant? By making arrow like this. Therefore here A1 B2 minus B1 A2, that is the value of this given determinant. And similarly, we can find out the value of dx using the rule of that determinant, that is C1 B2 minus B1 C2, and also find out the value of dy, that is A1 C2 minus C1 A2. Then using these values of determinant D, dx and dy, then we can find out the roots of given simultaneous equations. Therefore, there are formula to calculate the values of x and y have to used to solve the simultaneous equation. Then here x is equals to that is dx upon d, and for the finding value of y is equals to dy upon d. Formula are used to find out the values of x and y, and that are the roots of given simultaneous equation. Then first of all, you have to write the determinant for d, dx and dy correctly using these elements, then we can calculate the values of x and y using this formula. Then let us solve few examples from practice set 1.3, which is given in question number 3. That is 3x minus 4y is equals to 10. Then let us consider this equation number 1. Then see here the second one equation, that is 4x plus 3y is equals to 5. That is equation number 2. Then first of all we have to find out the values of, or we have to write the values of a1. See here, that is a1, b1 and c1. Then a2, b2 and c2 values for these elements. Then first should write the values, that is a1 is equals to 3, a2 is equals to 4, then b1 is equals to minus 4, considering the value of b1 with its sign. That means minus 4 is the value of b1, b2 is plus 3. Similarly, have to write the values of c1 and c2. c1 is equals to 10 and c2 is equals to 5. Then we have to write the determinant d. Then see here, d is a determinant, that is a1, b1, a2, b2. Then a1, 3, b1, that is minus 4, a2, b2, that is a2, 4 and b2, 3. Then we have to find the value of this determinant, that is d. See here, 3 into 3 minus 4 into 4. We should use the bracket here. Then to find out the value of this determinant, 3 into 3, 9, minus 4 into 4, minus 16. Therefore, 9 plus 16, that is 25. That means the value of d is 25. See here, d is equals to 25. Then we can write the determinant dx. See here, dx, c1, b1. Then see here, c1, 10. Value of b1 is minus 4. And c2, b2, c2, 5, b2, that is 3. Then we have to find out the value of this dx determinant. Therefore, 10 into 3 minus 4 into 5. Therefore, 30 minus 20. Therefore, 30 minus plus 20. Therefore, dx is equals to 50. Therefore, we have to write the value of dx is equals to 50. Again, we can write the determinant, that is dy. Determinant dy. See here, a1, c1 is the determinant in which elements are a1 and c1, that is 3 and 10. Similarly, A2, C2, that is 4, 5. Then find out the value of this determinant. 3 into 5 minus 10 into 4. Therefore, 3 into 5, 15 minus 10 into 4, 40. 15 minus 40. Here plus sign for 15 is there and minus is for 40. The greater number is 40. Therefore, we can write the value of this, that is 40 minus 15, that is 25, and the sign of greater number is given here, therefore minus 25. Therefore, here the value of dy is equals to minus 25. Then see here, we find out the values of three determinants, that is d is equals to 25, dx is equals to 50, and dy is equals to minus 25. Then we can find out the values of x and y. That means we can find out the roots of given equation. Therefore, x is equals to dx upon d. Putting the value of dx and d. See here, 50 upon 25. We get the value for x is equals to 2. And y is equals to dy upon d. Therefore, the value of dy and d is used here to find out the value of y. Therefore, minus 25 upon 25. Therefore, y is equals to minus 1. That is the solution of given simultaneous equation. That is x is equals to 2 and y is equals to minus 1. Then we can tally this simultaneous equation, whether that solution is correct or not, by putting the values of x and y in both equation. If it satisfies both equation, then the answer is correct. Then see here, the value of x is 2, 3 into 2 6, 6 minus 4 into minus 1, that is minus 4. But here 6 minus 4, that is 6 plus 4, that is 10. Similarly, the value of x is 2, that is 4 into 2, 8, plus 3 into minus 1, minus 3, that is 8 minus 3, that is 5. Then it also satisfies to the equation number 2. Therefore, our answer is correct. Then see here, by this method, we can solve the examples of simultaneous equations. First, from practice set 1.3. Then let us solve one more example from practice set 1.3. That is example number 3 from question number 3. X plus 2y is equals to minus 1. Let this equation number 1. Similarly, 2x minus 3y is equals to 12. Let this equation number 2. Then see here, that is the example number 3 from question number 3 from practice set 1.3. Then first of all, we have to mark here for the values of a1, b1, c1. See here, coefficient of x is nothing is there, that means there is 1. Therefore here a1, b1 and c1. Similarly, a2, b2 and c2 are there. First of all, we have to write the values of a1 and a2. Then a1 is 1 here, a2 is 2, and value of b1 and b2, that is b1 is 2 and b2 is -3. Similarly, we can write the values of c1 and c2. c1 is -1 and c2 12. Then using these values of elements, we have to write the determinants, that is D is equals to, all of you have to remind what are the elements used to write the determinant D, dx and dy. For D, a1 b1 and a2 b2 elements are considered there. First of all, write the determinant D, that is a1 b1, that is 1 2. We should not be use comma between these elements. Then a2 b2, that is 2 -3. Similarly, we have to write the dx determinant. dx determinant. Then see here, for dx determinant, c1 b1 elements are used and c2 b2 elements are used to write the determinant dx. Then see here, c1 b1, that is -1 2 and 12 -3. 12 -3 is written in the determinant. Similarly, the dy determinants. For dy determinant, a1 c1 and a2 c2 elements are values of these are used, that is 1 -1 to 12, that is here a1 c1 and a2 c2 elements are used. Then we have to find out the values of each determinant, and we have to find out the values of determinant carefully. Here calculation should be done. For this purpose, we have to make the arrow between these two elements, that means 1 into -3 minus 2 into 2. Therefore 1 into -3, that is -3, minus 2 into 2, 4. Therefore here D is equals to -7. Then find out the value of dx. See here, -1 into -3 minus, in another bracket, 12 into 2. Therefore the value of dx is -1 into -3, that is 3, minus 12 into 2, 24. Then value of dx is equals to 3 minus 24, that is -21. And the value of dy is 1 into 12 minus 2 into -1. Therefore 12 minus, in bracket 2 into -1, that is -2. Therefore 12 plus 2, that is the value of dy is 40. Then we have to use these values of d, dx and dy to find out the values of x. Then see here, dx is equals to dx upon d. Therefore here dx is minus 21 upon d is minus 7. Minus 21 upon minus 7, that is 21 upon 7, that is 3. Therefore here x is equals to 3. Similarly, we can find out the value of y, that is dy upon d. Putting the value of dy and d, dy is 14 upon minus 7, that is minus 14 upon 7. Therefore here minus 2 for the value of y. Then here solution of given equation is, simultaneous equation is 3 minus 2 is the solution of given simultaneous equation. We can tally these solutions by putting the value of x and y in both equations. Therefore here x is equals to 3. 3 into 1 3 plus 2 into minus 2, that is minus 4. That is 3 minus 4, that is minus 1. It is correct for first equation. Similarly, then the value of x is 3. 3 into 2, 6, minus 3 into minus 2, that is minus 6. Therefore 6 minus minus 6, that is 6 plus 6, that is 12. And it is also correct for second equation. Therefore our answer, solution of this simultaneous equation is correct. Then you can do the practice of solving simultaneous equations by Cramer's rule, using Cramer's rule. Then solve the remaining examples from practice set 1.3 for more practice in your textbook. Thank you.